everyone. In the previous class, we discussed about the classification of intact rock, and I also introduced you the concept of RQD, rock quality designation. So, today we will start our discussion on the classification of rock mass. Now, the difference I have already told you, the difference between rocks and rock masses, they are that when the rocks have the joints or the discontinuity, as a whole we call that as rock mass. So, let us take a look that how these rock masses they are classified. So, basically there are three factors on basis of which rock masses they are classified. The first one is intact rock properties, joint characteristics, and the last one is the boundary conditions. As far as intact rocks are concerned, its strength and stiffness or modulus they are used in design. In case of the rock mass classification, UCS of the intact rock is commonly used as a measure of strength. Coming to the stability of the jointed rock mass, this is significantly affected by the frictional characteristic along the joints between the adjacent blocks of rock. Now, these joint surfaces they can be stepped or undulated and very rough at contact points. So, at contact points what will happen is that you will get very high shear strength. So, for filled joints, it is the aperture width and the characteristic of the filling material which become more important as compared to the characteristic of rock wall roughness. So, in case if you have unfilled joints, it is the rock wall roughness that will govern the strength characteristic of the jointed rock mass, but in case if you have filled joints, it is the aperture width and the characteristic of the filling material becomes more important. Coming to the boundary conditions, these include in situ stresses within the rock mass and also the groundwater conditions. Now, groundwater has adverse effect on the stability of the rock mass. Why? Because if the groundwater is present, it increases the pore water pressure in the rock mass, and this results into the reduction of effective stress and therefore, the reduction of the shear strength. Therefore, it is extremely important for us to know the groundwater condition before we go for the classification of rock mass. Now, the question comes that what is the need for the classification of rock mass. So, here I have listed some of these points such as there are wide range of strength values for intact rock cores. So, how to classify only on the basis of intact rock cores, that becomes always a question mark. Then many parameters are there which describe discontinuities and rock mass. So, we need to really put them in some different subclasses to make a proper classification which is based on the discontinuities and the other characteristic of the rock mass. Then let us say all around the world different types of rocks exist. Now, when say two geotechnical engineers they are from different countries, so they should have the same language when they are referring to a particular type of rock mass. So, to design, to define that language, that technical language, we need to know that what exactly are the various classification systems of the rock mass. So, these are some of the points that one should have, or these points they give us the idea that why should we need the classification of the rock mass. So, different rock mass classification systems are available. Commonly used systems are rock mass rating system, which we call as RMR system, rock mass quality system, that is also designated as Q system, and the third one is geological strength index. There are other systems also, but we will be focusing only on these three, that is RMR system, Q system and GSI. Coming to the first one, that is RMR system. It was initially developed by Biniewski in 1973 at South African Council of Scientific and Industrial Research on the basis of his vast experience in the areas of shallow tunnels, and that too in sedimentary rocks. This system is also known as geomechanics classification system. Now, what is done in this case is that there is a particular site. So, this site is divided into some number of geological structural unit, and it is divided in such a way that each type of rock mass is represented by a separate geological structural unit. Now, the question is how to identify these different units. So, let us say you are traversing through that given site and see, suddenly you see there is a change in the color of the rock. So, that change may be because of the different mineral composition. So, what we do is we define a geological structural unit there, we demarcate it that okay, here it is the next unit. Similarly, let us say there is a joint pattern that is different, there can be the difference in the texture. So, there you have to take a call, you have to use your engineering judgment to define these structural units for that particular site. Now, as far as these rock mass rating system is concerned, basically there are 6 parameters which are to be determined for each structural unit that we have identified at the site. So, these parameters include the UCS of intact rock material, RQD. This we saw in the previous class, that how we can determine the RQD. Then joint or discontinuity spacing, condition of joint, then groundwater condition, and finally the joint orientation. So, what is done in this case is the ratings, they are assigned to each of these 6 parameters. So, as far as the first 5 parameters are concerned, that means you have to exclude the joint orientation from these parameters. So, you assign the rating to the first 5 and sum these up, that will give you the basic value of RMR, which will lie between 0 to 100. The last parameter, it is an adjustment to RMR considering how favorable or unfavorable the joint orientations are with respect to the project. Now, this project may include the construction of tunnel, maybe the dam foundation, or maybe related to slopes. So, based upon what type of structure it is, you have to see whether the joints are favorably oriented or unfavorably oriented with respect to that particular structure. Now, the values of this adjustment, it is negative, and it varies from 0 to minus 60. As I mentioned, that this is going to be dependent on the type of the project. So, it will be different for say tunnels or foundations or slopes. So, let us take a look that how do we assign the ratings to all these 6 parameters. So, first we will focus on these 5 parameters. we will assign the rating, and then we will try to find out that what is the basic value of RMR, and then we will make the adjustment for the joint orientation. So, here is the table which gives us the idea that how on the basis of UCS of the intact rock, how can we assign the rating to the first parameter and how these can be qualitatively described. So, in case of the first one, that is when you have the compressive strength greater than 250 megapascal, the qualitatively you describe the rock as extremely strong and its rating is going to be 15. Similarly, if it has the compressive strength in between 100 to 250 megapascal, it is described as very strong rock and the rating of 12 is assigned. So, likewise, if you just go through this table, the last one is extremely weak rock which has a compressive strength less than 1 megapascal, and the rating which is assigned is 0. So, when you have the compressive strength less than 1 megapascal, many rock materials in such situation would be regarded as the soil. So, you can see that there is a third column for the point load strength index test. So, in case if you are not able to conduct the UCS test, then maybe you can conduct point load strength index test, and on basis of their value also you can decide upon the rating with reference to the strength of the intact rock. However, for weak, very weak and extremely weak category, the use of UCS is preferred and we cannot rely on the point load strength in order to decide the rating for the strength of the intact rock. So, once you have the value of UCS for a particular rock, when I say rock means here I am talking about the intact rock, and accordingly whatever is the value that you obtain from the second column, accordingly you pick the rating from this column. Coming to the second parameter, that is rock quality designation RQD, and we have seen earlier that we can determine it directly from the rock course or indirectly from volumetric joint count, and say that RQD works out to be say 85%. So, that is the qualitative description for that is going to be good, and you can assign the rating of 17 for that type of rock mass. So, similarly, if you have poor category, then the rating is going to be 8. So, you see that as the quality of the rock mass degrades in this direction, the rating that is assigned to this parameter RQD is also reducing. Similar was the situation that we saw in case of the strength of the intact rock. Coming to the third parameter, which is the spacing of discontinuity. Now, these discontinuity, they may include joints, beddings or foliations. There can be the presence of shear zones or minor faults, or there can be any other surfaces of weakness. So, the linear distance between two adjacent discontinuities should be measured for all the sets. So, let us say that this is the kind of situation, say is the rock mass, and basically say here you have two joint sets. So, how do we decide that what is the spacing of the discontinuity? So, what we do is that two adjacent discontinuities, that is let us say this, and whatever is the minimum distance between these, that is going to be give me the spacing of discontinuity. But then this is going to be for this particular joint set. In case if you have to get the spacing for the other joint set, then this distance you should take between these two adjacent discontinuities. So, based upon the spacing, you can assign the rating here. Now, you see, if the spacing is large, that means in a particular volume of the rock mass, you will have less number of joints, and therefore, it is going to represent the better quality of the rock mass. So, in this case also, as we go from very wide to very close spacing of the discontinuity, or larger value of spacing to the smaller values of the spacing, the rating which is assigned to spacing of discontinuity, it also reduces. Now, in case if you have more than one discontinuity set, as I showed you here in this figure, then we have to find out the spacing of discontinuity for each and every set, and we have to take the value of the spacing of the discontinuity, which is the critical oriented set. That means that particular discontinuity is most unfavorably oriented with respect to the proposed structure, whether it is tunnel, whether it is foundation, or it is the slope related issue. Coming to the next parameter, which is the condition of discontinuity. Now, these condition of discontinuity, they it may be defined in terms of these parameters which have been listed here, that is roughness of discontinuity surfaces, their separation, length of discontinuity, then weathering of wall rock or planes of weakness, whether there is any infilling or gauge material in the joint. So, the property of that infilling material also influences the condition of discontinuity. So, take a look here. This table gives you the idea about the general description. So, in case if you do not have each and every details of those parameters that I just now discussed with you. So, if you have the general description of the condition of discontinuity, you can use this table and assign the rating. For example, if you have, let us say, slightly rough and moderately to highly weathered wall rock surface separation having less than 1 millimeter. So, that means it is this category. So, we can pick the rating as 20. Again, here you can have more than one discontinuity in the rock mass. So, which one do we need to pick? Whichever is most unfavorably oriented with respect to that particular structure, that joint we have to consider, and its condition only should be assigned the rating to be used for calculating rock mass rating. Now, in case if you have all the details available, say you have discontinuity length, separation, roughness, infilling, and the weathering status, then you can assign various ratings from this particular table, sum them up and find out the overall rating to be assigned to this parameter, that is condition of discontinuity. Coming to the fifth one, that is groundwater condition. For the projects related to tunnels, rate of inflow of groundwater in liter per minute per 10 meter length of the tunnel should be determined. If we are not able to determine this, then maybe we can describe a general condition in terms of, say, as completely dry or damp, wet, dripping or flowing. So, based upon this, we need to assign the rating for groundwater condition. Now, in case if you have the actual water pressure data that is available, so that should be stated, and it should be expressed in terms of ratio of seepage water pressure to major principal stress. Now take a look at this table and see how we can assign the rating. In case if you have the information about inflow per 10 meter tunnel length, that is in liter per minute, then you have to use this row, and there you have this ratio of joint water pressure to major principal stress. So, this is there when you have the information about the water pressure, but in case if these are not available, if you have only the general description with you, let us say that the groundwater condition falls under the category of wet, then what is the rating that you will assign? It will be 7. So, accordingly it will vary from completely dry to flowing condition, and corresponding rating will vary from 15 and it will reduce to 0 here. So, we have got the rating for all these 5 parameters. So, now what we do is we are in a position to find out the basic rock mass rating, that is the addition of ratings of the above 5 parameters which we discussed. Now, the question comes that how should we account for the orientation of discontinuities? Let us take a look. So, here is the table that gives you the idea about the adjustment for joint orientation. So, you see for different type of structures, different row is given. For example, for the tunnels it is this row that is to be considered, for raft foundations it is this row, and for slopes related problems it is the last row of this table is to be used. Now, based upon what is the orientation of the joint with reference to the orientation of the structure, you have various categories, whether it is very favorable to favorable, fair, unfavorable and very unfavorable. So, based upon that you pick the rating from this table. Then what should be the next step? We already have the RMR basic with us. Now, what we do is we pick the rating for the adjustment of joint orientation from this table, and we apply this adjustment to RMR basic to get the final value of rock mass rating. Another question before we do this or before we get the final RMR value, that how do we decide whether the joint is favorably oriented or unfavorably oriented. So, here is some guideline that is given in this table with reference to the tunnels. So, various aspects are given, whether the strike is perpendicular to tunnel axis. So, when we say strike, that means I am specifically talking about the strike of that particular discontinuity. In case if the strike is parallel to the tunnel axis, or if you have the joint that is irrespective of its strike. So, there also we can get some idea. So, the drive with dip or drive against dip. In case if it is drive with dip, if the dip is in between 45 to 90 degree, then it is very favorable. If the dip is in between 20 to 45 degree, it is favorable. So, likewise you have various condition based upon the orientation of the joint with respect to the orientation of the tunnel axis. So, accordingly you find out what is the condition of the joint orientation, whether it is very favorable or it is fair or it is very unfavorable. Accordingly, we can use this table to assign the rating for the adjustment for joint orientation. Now, since we have got this, the sum of the joint adjustment rating and the RMR basic that we have already obtained, that is going to give us the final value of RMR for that particular structural unit of the rock mass. The question is, what do we do after that? So, once we have got the RMR value for the rock mass, what we can do is we can have various information that would be useful in the some design and the analysis of various projects. So, let us say that the RMR works out to be say 90. So, it falls under the first category here. So, focus on this column. The classification of the rock mass as per the RMR system will be very good, and it will give you the idea about the average stand up time, which will be 20 years for 15-meter span of the tunnel. It will also give you the idea that what would be the range for the cohesion and angle of internal friction of the rock mass. In case if you have foundation related problem, then the allowable bearing pressure will be to the tune of 600 to 440 ton per meter square, and safe cut slope in this case is going to be greater than 70 degrees. So, similarly, once you obtain the value of RMR, you can choose that what is the classification of the rock mass, and then maybe you can choose the representative parameters such as average stand up time, shear strength parameters, allowable bearing pressure and safe cut slope with reference to that value of RMR. So, this is how we classify the rock mass using rock mass rating system, and once we know the value of RMR, we can have various applications as shown in this particular table to be applied to the rock mass under various projects, be it for tunnel, foundation related problem or slope related problem. So, thank you very much. So, in the next class, we will discuss about the other classification system, that is Q system and GSI. Thank you.